Me to go through this problem, section 9.3, problem 17b on page 476. It's a pretty fun problem. And yeah, we didn't really cover this much in class, so I thought I would go over it here. Let me see what I can do here. All right, so here's the problem. It's a football stadium somebody's trying to build. And the red ellipse is the smaller ellipse right here that you see graphed. This is the equation to the ellipse. And then you see where I have graphed it down here, the red ellipse. Then the orange ellipse, they gave you this equation, and I graphed the orange ellipse. And now the seats are going to be put where I have all the blue colored in, between the two ellipses. And now what they've told you, and this is really kind of the trick to the problem here, and let me see if I can kind of emphasize this enough. Each of these little tick mark here, if you look right here, this is 10. That's going to represent 10 meters. This is going to represent 20 meters, 30 meters, 40 meters, 50 meters. Do you see every tick mark is 10? So keep that in mind when we're trying to calculate the area. What else can I say? You know, look at the red ellipse. It is greater than or equal to 1. And so notice how the blue region is bigger than the red ellipse, but it's less than or equal to 1. It's smaller than the orange ellipse. So again, it's everything in between. All right, they tell you that to calculate the area of an ellipse, you take pi, the area of the ellipse. Now this is going to be the red ellipse, and by the way, if I have to color this in or something, that's going to be this area right here. Okay, it's going to be this area right here. Do you get what I'm saying? It's that area. Okay, that area, they say, of an ellipse, you're going to use the equation pi times the length of the semi-minor axes times the length of the semi-major axes. So this is a little bit the trick right here. So I'm going to use pi. They said to use 3.14159. I'm going to use pi on my calculator, okay? And I look over here. A is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Do you see that? It's 100. Okay? And B is 10, 20, 30, 40, 50. It's going to be 50 here, right here. So if I work this out all of the way right here, sorry about that, to hear the phone ring, sorry. Sorry about that. All right. So if I work this out, I'm going to take pi times 100 times 50, and what do I get on my calculator? I take, I'm going to get 15,708. And you could do that on your calculator, 15,708. And remember, this is square, it's area, it's square meters. It's 15,708 square meters fit in this ellipse right here. Okay, that's the area of the red ellipse. Now, what I'm going to do to find the area of the blue, I'm going to find the area of the orange ellipse. So let's do that next. And so I'm going to come over here, and the area of the orange ellipse is going to be pi times AB, same thing. This is the area of the orange ellipse, which is going to be the whole thing right here, okay? It's all of the orange. And so what I want to do here is, let's see, it's going to be pi times, well, you know what, I want to erase that. I don't want that to stay on here. Sorry, just a second. I want to get rid of that. There we go. Pi times AB, but you know what I'm talking about. It's the area of the whole, everything within the orange ellipse there. So this is the whole orange ellipse. So it's going to be pi times AB. And now let's think about this. A with the orange ellipse is going to be, I'll do this one right here. It's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So it's going to be pi times 120, the length of the semi-minor, or actually it's a semi-major axis. And then down over here, it's 10, 20, 30, 40, 50, and you can't really see it, but 60, 70, 80, 90, 100. And so it's going to go up 10 units there. Okay, so it's going to be 120 times 100 times pi. And I did that on my calculator. I got 37,699. 699 square meters. Okay. Now to find the area of the blue, of course, we're just going to have to take the area of the orange and subtract off the area of the orange, and we're going to subtract off the area of the red ellipse, which is 15,708. Okay, so I did that on my calculator, and I just don't want to bring a calculator up and take the time, but I did that on my calculator, and I got 21,991. 21,991 square meters. Now, we're not done. Okay, that's the area of the blue region. It's 21,991 square meters, but it says in the problem 17b, it says that every chair takes up 0.8 square meters. Every chair takes up 0.8 square meters. And so, you know, if every chair took up 1 meter, I could put in 21,991 chairs. Okay, but every chair takes up a little less than 1 square meter. So do you get it? If every chair took up 1 square meter, I could put in this stadium almost, well, I could put in the stadium exactly 21,991 chairs. Okay, but they take a little less than that. So I'm going to just take that number, 21,991, and I'm going to divide it by 0.8. Okay, it's to find how many squares. And so that's all I did. And so when I did that, I got the final answer here. I think it's the final answer. I'll check and make sure, which probably would have been a good idea to do before I did this video. But 27,400, and just rounding it off, I'm getting 27,489 chairs. Okay, and I got that by taking 21,991 and dividing that by 0.8. Right? So then I got 27,489 chairs. And just, yeah, 17, that's the answer. Okay? All right, thank you guys. See you later. Okay, bye-bye.